concerning greenhouse gases. The most important is not CO2, it's water vapor. Can you explain us this system, how it works?
Yeah, so the atmosphere is obviously a very complicated place. And the Earth is in a careful balance between the heat going in and heat going out. And so when the heat accumulates in the atmosphere, we have a general warming. So CO2 acts to amplify the effects of water vapor in the atmosphere. And we're all familiar with water vapor. That's what causes rain and so on. So it's not a very simple set of processes. And it's one of those things where people will say, well, there's a lot more water vapor than carbon dioxide. Yes, that's true, but that does not mean that carbon dioxide is irrelevant.
And also, I was reading that clouds are very important, and 60% of clouds is above the oceans. And this part of clouds, that this is not calculated well in these IPCC assessment reports. Is it right?
Yeah, so I mean, obviously, modeling the global Earth system is an enormously challenging task, and all credit to the scientists who take on that challenge. There's a big difference between being able to accurately predict what's going to happen in the climate system going forward versus understanding that we're changing it and the future has some risks and may be fundamentally unpredictable. Clouds that you identify are one area where climate models are far from perfect. And so I try to tend to view climate models as a qualitative tool. They tell us something about how we're changing the system and the risks we may face. They are not crystal balls. They don't tell us what's going to happen with a lot of precision or accuracy, but they do tell us that we are affecting the climate system. And that, from a policy perspective, that should be enough to get us to the starting line.
And what has the biggest impact on clouds? Is it CO2 or water vapor, or there is some impact from sun cycles?
So the answer to that question is yes. Water vapor is obviously the most important factor for clouds because that's what clouds are comprised of. Carbon dioxide changes heat and heating patterns. That also changes clouds. But also any place where there's, for example, agriculture and irrigation, and we change the land surface. Actually, my father, who's retired, has been a pioneer in work on land surface processes and how they affect the climate system. That affects where it rains, how it rains. Urban centers also affect clouds and how they develop. Anyone who's seen very large forest fires, perhaps in the news or online, sees that forest fires create clouds and they create their own weather. So there's a lot of processes that affect clouds, and that's one of the things that makes it very difficult to model them in the sophisticated climate models.
What about sun, total sun irradiations? Is there any effect from sun to creating clouds?
Yeah, I mean, obviously, if you go outside at night and you go outside the next day, you can feel the sun yourself, and the sun is central to the Earth system and global climate. There's a lot of discussion and debate over the relative role of solar changes over time. The consensus views right now of the IPCC are that the solar factors are a smaller factor, much smaller factor than the forcing that we're causing through the emission of carbon dioxide and through the burning of fossil fuels.